Hello, I'm JB Alshehabi. This is my Arduino Simple project for CSCI 2350. Now, before we get into the actual physical build of the project and putting the Arduino board together, a good idea is to hit up Tinkercad and virtually design it. Some benefits of doing this is one, you can simulate the build and see and test if your configuration is going to actually work out or not. But most importantly, you can also save yourself from destroying components. Maybe an LED light isn't so expensive, but there are other components that may be, or shipping, whatever it may be. You know, you don't want to be put in the spot. But for instance, if I wire this LED light direct to power and to ground without the use of a resistor in between, and I simulate it, boom, it'll show that the LED light will explode or will be rendered useless after it's powered up physically. So good feature for Tinkercad. I didn't use it at first, but I definitely started using it. One downside is that there's not a lot of inventory to choose from, but they do have the basics. As far as my project required one Arduino board, a breadboard, 10 220 ohm resistors, and 10 LED lights, and one analog potentiometer knob. You can't really tell, but this is 2D flat, but just like a little turn dial. So I'll do one walk through it and then super speed the remaining parts of it. Now for the first step, what I want to do is I'll dedicate half of this breadboard on the left for all my LED and resistors, and I'll put my knob on the right. I've situated the Arduino vertically just for arrangement and organization's sake. When the physical build is done, it's going to be a hot mess of wires, but potentiometer I will stick around here, and I'll start my LED lights on the 30th row at the top. Now the 220 ohm resistor is going to go into the ground terminal, which is the shorter wire of the LED light. This bent crooked wire here signifies that it's longer than the other. That's for your power and your voltage. And then we will keep it orderly. It's like my build, and what I will do is I will use green for my voltage and connect it to digital pin 2, and we'll start it there. Let's not do diagonal, let's keep it in order. Let's go here and then cut across. All right, okay, I like that. And then we will do blue for the next light. Yes, I'll alternate like that. Now I'll need to connect the actual breadboard rails to my Arduino, and I'll go ahead and take the positive, and we could run it out here, go down to my 5-volt, and then go back in. I like that. And we'll do red. Like that. And then we can grab our negative rail, try to follow the same pattern. This one. Make it black. Boom. Okay, so now we have our layout schematic here of the Arduino breadboard project featuring 10 LED lights and 10 220 ohm resistors and one analog potentiometer. The upgrade is intending on using an ultrasound sensor or some time delays. Who knows? But for now, this is the project here before the physical build, and running the code with the Arduino software for Windows. Okay, so as far as the code for this project, the LED bar graph project, the code can be found on the Arduino application itself. It's on there by default. This was created by Tom Ego. Sorry if I said the name wrong. Back in September of 2010. The project starts off with calling the two constant ints, the constant integers. These two values won't be changing. The analog pin where the potentiometer is going to be plugged in, out of the 6 slots, a 0 will be used. And we have a total of 10 LEDs for this project. So use in an array and for some iterations later on. Now going into our first line of code, after the constants, we're going to be calling an array, initializing it, and setting values from values 2 all the way up to 11. On the Arduino board, 0 and 1 are reserved for other functionalities. So for us, the 10 LED lights are going to be assigned one individually to each one of these value slots. Now with the setup line of code, before actually going into the program that's going to be running this project, we need to initialize and set all the pins to output mode. And for this, a for loop is used. With the for loop, the 3 statements, you have your statement number 1, and this LED equals 0. That's your initializing statement before going into the iteration. Statement 2, this LED is less than LED count. That is your test statement. And then this LED plus plus is what is going to be executed at the end of the iteration. Now, if you go into the actual code block and it passes the test statement, then pin mode LED pins, this LED is set as an output. This is the main loop of the project of the Arduino programming. This is going to continue on and on and on. The iteration will run through it until the project is deactivated or the power source is disconnected, whichever it may be. But going through it, we initialize a variable sensor reading. The sensor reading is going to take the analog read that we declared earlier that would be coming from the potentiometer. What that reading is going to do is it's going to map it similar to kind of like an XY on a graph you could imagine, or taking the ratio from 0 to 1023 and giving it an equivalent ratio with the 0 to LED count, which was initialized earlier as a constant equaling 10. And then within the loop itself, the same 3 statements as previously used in the setup iteration is going to be used again. This time, the test is also going to go through within the code block. If the LED light, if this LED is less than LED count, then it will go into the if statement block, this LED less than LED level, and digitally write that value of high, which means on, the highest it can be for the LED level, or if not, else, the else block, digital write LED low, which is equivalent to off.